Hello everyone, welcome to this next video on field theory. In this video we are going to see what is a subfield, right? So in the previous videos we have seen what is a field. It is a set defined together with these two operations, forms an additive abelian group, forms a multiplicative abelian group where you exclude the 0 from the set because for 0 we cannot define multiplicative inverses, and we have the distributive laws combining these two operations, right? We already know that. Now the question is that if we take any subset of this set F, right? Let us call this as K. So then K is a subset of this set, then can we call this as a field? Or if you take any subset of this set F, then can we call that as a subfield of this set F? So the natural question is, when you can call this subset a subfield? So the answer to this question is that if the algebraic structure, that is field in this case, we are dealing with fields, inherits the same properties as that of the parent field and obeys the same axioms, then we can say that the given subset is a subfield of the given field, right? So let us look at the definition. Formally, let us define what is a subfield. A subfield, let us call this as K, of the field F is a subset of F. It basically is a subset that is itself a field with respect to field operations of F. That is, you can say that from a bigger field, you have just taken a very small subset out of that, and which itself is a field. You can call that as a field independently, right? So that is a subfield. So let us look at some examples. We have studied previously that about this set, the set of complex numbers. This set, together with the operation of addition and multiplication, it is a field, we know that. If you do not remember, you can watch video number 3 of this playlist, right? So this is a field. So can we say that this field C, is this a subfield? To define a subfield, you must be thinking we must need some bigger field out of this. So do we have some field which is bigger than the set of complex numbers? Just think about this. The answer is no. There is no field which is bigger than this field of complex numbers. We'll see the reason to this eventually in the later videos, right? As for now, this is the largest field that we have, the field of complex numbers, right? So this is a field, we know that, but it is not a subfield, right? So let us now look at a subset of this field. What is that? That is a set of real numbers, right? So we have already seen that this real number, together with the operation of plus and multiplication, this forms a field, right? Moreover, this R is a subfield of the field of complex numbers, right? This is true. Therefore, we can say that the set R is a subfield of the set of complex numbers, right? Now let us look at another subset, that is a subset of rational numbers, right? This is a subset of R as well as this is a subset of complex numbers, and we have already seen that this, together with the operations of addition and multiplication, this is a field, right? Therefore, we can say that the set of rational numbers is a subfield for both the set of reals and complex numbers, right? Now, we know another subset of this set, that is the set of integers, right? Now, this set is a subset of rational numbers, which is a subset of real numbers, and which is a subset of set of complex numbers, right? Set of complex numbers. But this together with this operation, this is not a field. You can check all the properties. This is not a field. If this is not a field in itself, so we can say that this is not a subfield of any of these, right? Now, let us look at another example. Another example is this is a field ZP where P is prime. This is a set consisting of equivalent classes 0, 1 up to P minus 1, right? This bar denotes class, equivalent class, and it contains all those elements like this class P minus 1. It contains all those elements which when divided by P leaves a remainder of P minus 1, right? So this set together with the operations of addition modulo P and multiplication modulo P has no subfield apart from itself, right? So this is a very interesting thing to see, and we will see this in the upcoming videos that why is this so, right? That is it for this video. Thank you for watching.